And the reason for that is that it has generally been difficult to write a database management system for handling geometry. But during the last years it has been possible to do that, and then the software vendors have been able to write programs that store all data in databases.
Yeah.
And if you're interested in this topic, you should later on go to the course Algorithms in GIS, where this topic is discussed in more detail.
And also we'll be returning to the geodatabase from Esri in a later lecture in this course.
Yes.
There are different kinds of databases. First we have the hierarchical database. It's where you have the hierarchical tree structure, similar to the XML files.
Yep.
You have a root node and it branches out to the leaves.
Yep. And a network database is something similar, but in this course we will not really discuss these two types of databases.
It's just for orientation that there exists other types of databases than the relational.
But these two, the hierarchic and network database, they are mainly of historic interest. They were mainly used in the 70s and early 80s, but nowadays they are very uncommon.
Mm. Which brings us to the topic of this lecture, the relational database. It's by far the most common type of database because it's very flexible, pretty easy to use and so on. And it's been around since the late 70s or so.
So I would say, I don't know, but roughly about 90% of all databases, or even more than that,
yeah,
are relational databases.
And quite recently there has also been an upswing in the object-oriented database, winning a little bit more ground. The Esri geodatabase is one example of an object-oriented database.
Or in a sense, it's actually a mixture between an object and a relational database, because there is a, you say, a grayscale between them. So sometimes they call this type of geodatabase for object-relational database.
Yeah.
The theory about object-oriented databases we will go through in later lectures in this course. So we will leave this topic for today.
Yeah, and we'll focus on the relational database. First, some terminology. As we said before, you don't actually communicate directly with the database. You use a management system to do that. So in this picture we have the user, which communicates with a relational database management system. It's usually shortened to RDMS. And this is the system which receives commands from you and executes that on the database. Commands can be retrieve information or update information or delete or whatever.
So a main advantage here is that the database language which is used between you and the database management system, this is standardized.
Yeah.
Which means that it's easy for different programs to communicate with the same data through the database management system.
Yeah. That's the whole point of using the management system, or one of the points here. Why should you use databases? Well, for one thing, redundancy can be reduced or controlled. That is, it's less of a risk that you have the same data at different places. So you can have it all at one place instead of 3 or 4 or 5 places.
So redundancy is it's a measure of if you are storing the same information in different places. Okay, and that also means if you are storing the same data in different places, that if you are changing it in one place, the database will be inconsistent.
That's also one thing that can be avoided
if
you use databases. because you can set up some rules of how you can manage the data and how you store it and so on.
Okay.
So let's say, for instance, if you have two objects that are dependent of each other, one object cannot exist without the other, you can set up a rule: if one of them is deleted, the other one is also deleted.
Okay.
Data can be shared. It's very easy to access a database. It doesn't have to be on the same computer. It can be just about anywhere in the world, because you have the database management system, which is standardized, so it's very easy to communicate with the database.
But if I want to retrieve the data, so if, for example, I have data stored in a file, shouldn't that be faster to do that than rather trying to first communicate with the database management system and then to the files? That should take longer time, or?
Well, it depends. Usually it's very fast to access a database because it has some techniques that makes the search a bit faster.
Like the index techniques, or?
Exactly. Okay. Like, for instance, if you search for a file in your computer, it can take a very long time if you look for a specific file on your computer.
Okay.
But if you search for a file in a database, it takes a split second.
Okay.
And that's why we have the fast retrieval of data. And also you have the security. The database management system has some security features that will help you to protect your data. So you can set up rules on which person can access this and so on. You also have the integrity that's closely connected to